Hey folks, it's me, and this is going to be an elementary introduction to trigonometry. I'm making this mostly for my elementary students, so it may be a little basic for some of you who are a little more advanced, but nevertheless, you might find it useful anyway. This video is going to be broken down into two parts, after which I will add some more sections, but the first section is going to be the basics, which is going to explain what is a radian, what are sine, cosine, and tangent, and then the next part, the next video, is going to explain how we can solve sine, cosine, and tangent for some basic angles, and then we're going to solve some basic triangles with that knowledge. Once we're done with that, we'll move on to a little more advanced stuff, but in the meantime, let's get started. So, right off, what is a radian? Well, a radian, in its simplest sense, is the ratio I know that's terrible writing, but basically it's the ratio of a radius to an angle. But the way that we define it, though, is we don't actually measure it like you do normally. Here we're going to call this theta, the Greek symbol that looks like an egg with a belt around it. Okay, the way that we actually measure radians comes from the fact that we measure it according to the radius and then the segment of a circle. Okay, so we're measuring this relationship here, which is how long this is to how long this is. Is, as we said, it is the relationship itself, okay, of the segment over the radius. So when this segment is the same size as the radius, then we get 1, and that's 1 radian. Now 1 radian is approximately 57.3 degrees, roughly. Really is 57.2958, but we don't really need that crazy accuracy. So if you think about it, okay, an entire 360 degrees is going to equal roughly what we would call 2 pi radians. And you'll see why, by the way. As a matter of fact, think about it this way. If we measure this, okay, now imagine the radius, okay, if we measure an entire circle, the relationship between radius and circumference, right? And that is that circumference equals 2 pi r. And in this case, S, if we measure the entire 360 degrees, we're measuring 360 degrees. We're measuring also the circumference, right? So in this case, okay, S equals 2 pi r. And if we use this formula above here, then we say theta, when we do a complete circle, equals 2 pi r over r. The r's cancel, and so for an entire turn, we get 2 pi radians. As I said, that's why we say that 360 degrees, which is a circle, is about 2 pi radians. Now, why would we use this when you've been learning degrees and they seem so useful? Why move on to something more? The same reason we move on to many things, which is later on, radians will be a much better use. They are absolute, unlike degrees. As a matter of fact, the very word degree should tell you that there is no easy way to, it doesn't have an absolute value. And so when you are actually doing calculations without an absolute value, you're going to have to be constantly adjusting for it. Okay, so later on you will learn that in calculus you can adjust for the degree. For example, if we just, we will later talk about sines and cosines, and if we wanted to derive, we call it d over dx. Don't worry if it doesn't mean anything to you now. I'm just explaining this, okay? D over dx of sine of x is going to equal cosine of x if you're using radians. If, though, you're using degrees, d of dx of sine of x is actually going to equal pi over 180 times the cosine of x. So, you add this extra complexity here. It's no fun. I mean, right now, when we convert, as a matter of fact, we're going to have to do the same thing, but at least we're only going to do it for a little while, and then we're going to stick to radians. So that takes me to the next point, which is converting between radians and degrees. Okay, and to do that, honestly, I never try to memorize which direction. I just remember it's pi over 180. Now, depends on which direction we're going. It's either pi over 180 or 180 over pi. So here it is. So you say you want to go from radians to degrees. First of all, remember this. This is why you don't really need to memorize. Just remember pi over 180, and you can flip it as you need. Okay. Now radians usually only go from 0 to 2 pi, whereas degrees go from 0 to 360. So think about this. Just think for a second. If you have some value in radians, say we have pi radians, okay? How much would that be in degrees? Which one of these two do we use? Well, if we used pi over 180, we're going to get a tiny number. If instead we used 180 over pi, we're going to get a somewhat respectable number. And that's exactly what we do. So radians to degrees is 180 over pi. And if you notice, that's going to give us 180 degrees, which is exactly what it is. Okay. Now, if we're going from degrees to radians, okay, well, now let's say we've got 135 degrees. Okay, well, without knowing this, assuming we didn't know this, we want to convert. Now, I said degrees is a big number. We're going to convert it into a smaller number. Well, which of these two factors will do it? 180 over pi, that's like a 60, well, that's a 60-ish number. Well, no, or the 57 number, but anyway. The point is, this number multiplied by that is going to make an even bigger number. So that doesn't work. Instead, you realize you've got to convert it to a smaller number, so do pi over 180. We notice that 135 over 180 times pi. Okay, well, this is just 3 over 4 pi. So we'll just call it 3 pi over 4. So let's move on to the next step. This is a totally incomplete definition, okay? But for right now, we're just going to use it this way, okay? And that is that sine is the relationship of the opposite of a triangle. Oh, by the way, all these definitions are based on a triangle, to the hypotenuse. Similarly, the cosine is the relationship of the adjacent side to the hypotenuse, and the tangent is the relationship of the opposite to the adjacent. And if you haven't heard it now, Usually, everyone remembers it by the mnemonic SOHCAHTOA. Very simple. SOHCAHTOA. Okay. Something else I want you to note, though. Okay, when we're talking about sine, cosine, and tangent, since you've never done this, okay, normally everything on this side here, when we measure triangles, these are lengths. These, on the other hand, are radians, or angles. We'll call them angles right now. Okay, so now another way to define this is by using what we call a unit circle, which is a circle of radius 1. Now let's imagine that this circle is a unit circle, so it has a radius of 1. Okay? And on this circle, our radius, as I said, is 1. Now, if we draw right triangles here, always have a right triangle here, okay? Now look at this. The angle of this guy here, this is theta, okay? This is r, but this also happens to be the hypotenuse, okay? Now, theta, if you think about it, the opposite side of theta is always the side that is on the other side. So this is opposite. Oops, let me make that a little less ugly. This is opposite, okay? This is adjacent. So, if we look at it this way, here we can state that the sine of theta equals the opposite over hypotenuse. Now, I said the circle is a unit circle, which means that the hypotenuse is length 1. So we already know then, in this case, the sine of theta is merely whatever the length of the opposite side is. Okay. Think about this. If the angle were to be 0, if theta equals 0, so you have an angle of 0, this is completely like this. Okay. Well, then sine of theta would equal 0. Now, if theta were 45 degrees, okay, in radians, that would actually be root of 2 over 2 radians, okay? And that would actually be pi over 4 radians. Normally, we don't need to write the word radian, by the way. We just leave it as a number, okay? If you need it, you can call it rad, but technically you don't, okay? But anyway, the sine of this value of pi over 4 is equal to the root of 2 over 2, which is roughly 0.707. Now, if theta equals 90 degrees, notice we're going a full revolution. We're going to do not just a half revolution, but in this case, we've got pi over 2 radians. Now you may be wondering, where am I getting that from? From the previous calculation. Okay, and so this is the sine of pi over 2. And this equals 1. Now, if theta equals 135 degrees, that's going to be, we already said, 3 pi over 4, and the sine of 3 pi over 4 equals the root of 2 over 2 again, 0.707. Okay, and theta of 180 degrees equals pi radians, and the sine of pi. And you can do all this, by the way, by following this triangle. I'm just calculating these things out. Is 0. Okay, because look, this one is 135. That means that we'd be doing it from here. Oops. Let me drive it a little better. There we go. So we'd be doing a measurement from here to here. Okay. Now, if we continue, by the way, I'll just give you some more. 270 would actually equal -1. And we go back to 360, of course, is the same as the sine of 0. I'm sorry, 2 pi. So the sine of 2 pi equals 0. Now here's the cool feature that I was going to try to show you, okay, which is if we plot this, okay, with the x being degrees and the y being the actual sine function, so sine of x function, okay. Remember, this is the sine of x function. This is what's coming out, right? Look at these. If you noticed, the highest value it gets is 1, and the lowest value it gets is -1. Okay. So we probably have to make it go like this. Okay. We begin at 0, 2 pi. This will be pi. This will be pi over 2, 3 pi over 2. Okay, and here's what happens. Here we begin at 0. And if we plot it, we notice this is 360 degrees, so this is a full revolution. This is 180 degrees. This is 90 degrees. Here's the cool feature, is when we plot sine of x, what began as just the ratio of a triangle, okay, turns into this weird wave-like function. And later on, we're going to use this for a ton of things. I mean, just that we're going to use it more for this probably than we will for the triangle features, although both will be useful. Now, to add some interesting twists to it, since the cosine is the adjacent over the hypotenuse, if you test it, you're going to notice that the cosine of 0 degrees begins at 1 rather than 0. And the cosine of pi over 2 actually goes to 0. Cosine of pi becomes -1. And so on. And this is a cool feature because the cosine function then goes from here to here. I'm sorry if it's not that accurate. My drawing skills are quite bad. Okay. So, here you go. Okay. Now this is an awesome development. Now if you want to see the tangent function, you got to keep in mind that the tangent function is kind of weird. I'll just kind of show it real quick here, but we actually got to go backwards here a bit. Oh, and by the way, these all would spread in this, would continue going the way they are. Okay. Now, the tangent function, if you measure these opposite over adjacent, think about this. The tangent of 0 degrees is going to be 0. The tangent of pi over 4 is going to be 1. And the tangent of pi over 2, let me show you this one. The tangent of pi over 2 is going to be the opposite over the adjacent, but remember, the opposite is going to have a length of 1, and the adjacent is going to disappear. Look up here and notice what's going to happen when you're straight up. The adjacent goes to 0, and so this becomes undefined. So we can't do anything with it. Okay? So this function actually looks kind of like this. And on this side it will go like this. Now, in theory, it will keep doing this so that it crosses this way. And it keeps doing that. I don't want to make this any more confusing, but you kind of get the idea. Oh, and this, like I said, it will never really touch. It'll just keep going. It should not touch these values. So each one of the functions is kind of weird. There's going to be a ton of things. I mean, we could spend the rest of the day talking about this, but at least I thought I'd open up your mind to, one, the actual uses of the sine, cosine, and tangent functions, which are right here. Just remember these. And two, a little bit of intuition as to why they are also plotted this way, why they show up. Do this yourself, with the cosine function or with the tangent function, and prove it to yourself, because that's the only way you're really going to start to get it, okay? So now let's move on to the next step.